functionalities, feature, data sets like the Sentinel and so on. I think we can discuss them in these question and answer sessions. If it is something like help desk is more for a specific problem you're experiencing on your own platform, then I would suggest to have it during the break. Let's see, or if there is time also in the general questions and answer sessions that you see indicated in the agenda. But okay, we are going to find some time for that indeed.
All right, thank you.
Thank you, Kenneth. So, is there anyone on the floor who has, some additional observations of the agenda? It could be related actually to your specific issue that you have been facing on the e-station, or you probably you don't have an e-station and you want to, you want to interject some way or the other. Just let us know. Otherwise, we will start the session, and probably in between you can ask the questions. I don't know how you feel about that.
Yeah, that is fine for me.
Okay, Marco, I suggest that we start because I don't see any. Okay, I don't see anything on the chat for the agenda. So I will just pull out my screen and allow you to share yours. Okay.
Thank you very much. So I'm sharing my screen just to present a very couple of slides on the JRC. So the Joint Research Center, I don't know how you are familiar with the European Commission, which is actually the European counterpart of the African Union Commission. And Joint Research Center was established back in 1957 as a really specialized center for the nuclear research. And now it became the Science and Knowledge Service, reference service for European Commission. So we are to provide scientific information for the European policies. The site, the center is actually very large. It includes more than 3,000 people that are sitting in 9 different directorates in 6 different sites over Europe. So you see Northern Europe, Brussels, Petten in the Netherlands, Kiel in Belgium, Karlsruhe in Germany, Seville in Spain, and we are here in Ispra. Some of you visited our site here. Is very close to Swiss, is in northern Italy. So at JSC, we have been, as already mentioned, participating very little in Puma, but then fully on board for the IMSD, MESA and GMS in Africa initiative that is going to end actually not this year, but at the end of 2021. And then European Commission and African Union Commission are arranging a continuation for this project in order to extend into the next decade. Just very brief introduction from my side in order to mention our institution. I think now we can go more to the contents. So I'm gonna give the floor to Juliana in order to start with the first presentation. If there is no any request, please do not hesitate to ask any question in the chat during our presentation and live, also maybe opening the video as well in the questions and answer sessions. Thanks a lot. Please, Julian, over to me.
Thank you, Marco. I just wanted to share quickly the DLP before we start, if you don't mind, in just half a minute.
Indeed, I saw him. Yeah, clearly.
Because, okay, let me share it. So yeah, we have the digital learning platform where all the resources are, well, I don't know how many of you actually managed to access the resources, but we have registered all of you, and we'll be adding some more people who are not on the training, but they would like to follow on the materials. Yeah, I see there are some that have not accessed. So it's a call actually to log in here at the digital learning platform. I will send the link on the chat. Be on the lookout to actually log in. We used your primary email, all lowercase, as your username, and then the password. I'm going to post it on the chat. So sorry for that, Julian. You can continue.
Thank you very much, Meshach. Okay, I'm going to share my screen. Can you see my screen? Hello?
Yes, yeah, good.
Okay. Okay, so I will start with session 1 of the eStation usage. Session 1 is going to be an explanation of the core concepts, let's say, of the MESA station. I will address first the concept and architecture of the MESA station, GMS and Africa station. Say something about the hardware architecture and software architecture. Then I will show you the application's main features. And the next step will be to show you the location and organization of the Earth observation data, so that you know where the data is on the eStation, on the MESA station, in case you want to use the data in your own tools like QGIS or Envy or any tool that you would like to use. Then the session will end with an overview, of the analysis application, where I will show you the key concepts quickly of the analysis tool. So the challenges for Earth observation data for the thematic users. There are many challenges for the thematic user before they can start really to do their analysis on the Earth observation data. First of all, you have to download all the data that you need, and in many institutions the internet is not available or not continuous or very slow. Then also the access of the data, quality and suitability. So if you have to, as a thematic user, download the Earth observation data yourself, you have to find it, first of all, and then see to it that the data is quality checked. And also best suited for your specific application or region. Manage complexity. So Earth observation data is available in many different formats. You have to be able to read all these formats in your application to do your analysis. And actually, the eStation is trying to remove all these restrictions, let's say, or challenges for the thematic user. easily perform pre-processing, long-term averages and or statistics and anomalies and temporal composition. So when you have acquired all the data that you need, you would like to do some statistics and create derived products out of those observation data that you have downloaded. So with all these challenges, the eStation 2 has been created to remove all these challenges for the thematic users and go from data to information. So the data analysis challenges is many platforms, sensors and formats, various time and space resolutions, ensure your satellite continuity, consistency for long time series. So all this part has to be is all automated on the eStation, so that the thematic user can simply do the analysis and interpretation of the Earth observation data they are interested in. So it is reducing the remote sensing burden and increase the time for analysis and interpretation. This is actually the main concept of the eStation 2. As Marco already shown, the eStation has been created since the AMES project, and then after the MESA project, and now the GMS in Africa project. So we'll skip this part. I wanted to tell you that the slides are actually available in the GMS training in the course. So if you go to the course, you can click here on the presentation slides, and then they are downloaded automatically, so you have also the slides here if you want the slides for further reference material. So how is the eStation, what is the overall architecture of the eStation, of the MESA station? The MESA station comprises of 3 PCs. PC1 is the receiving station, which is connected to a satellite disk, where the data coming from EUMETSAT is coming in. This data is filtered then for the data that are of interest of you, and the data that is of interest of you is copied to PC2, where PC2 ingests the incoming data into the system and starts then processing all the derived products that you are interested in. And PC3, so PC2 is a processing server, and PC3 is used to do the analysis. On the MESA station, you will also see, that the user interface of PC2 is in nominal mode. That is maybe a bit technical for you. Nominal mode is saying that the system is up and running correctly, let's say. There is no PC that is corrupted or something. So in nominal mode, PC2 the user interface does not comprise the analysis tool. Only on PC3 there is the analysis tool, where you can do your analysis as a thematic user. So most of the time you will be working on PC3 of the Mesa station as a thematic user. The data can then, of course, be taken from PC2 or PC3 and used in different other tools like Spirits, NV, or Grass. Now something a little bit on the hardware and software architecture. Actually, I'm not going to say much about the software architecture, but more about the hardware architecture. So this is a little bit more technical. So there is outdoor equipment with a satellite disk and an LNB connected to with a coaxial cable to PC1, and then this is all indoor equipment. There is then PC1, PC2, PC3, and they are all connected in a small network, together with an UPS, which is needed to ensure continuity when there is a power drop. Then the UPS will take over the power and supply the power to all the three PCs, so that the data can keep on coming in, and you can do your analysis. I hope that this is more or less clear to everybody. I don't see. Sorry. Okay. So, as I stated already before, the Station 2 is, here is actually missing something, is an acquisition, processing and monitoring system. Under the processing part actually is the copy of the Earth observation data from the receiving station or other sources, maybe from the internet. Format the incoming data into a standard format, which is GeoTIFF. So all the incoming data is converted to GeoTIFF and ingested into the system. Once it is ingested into the system, the incoming data, there is a list of processing chains that compute then from the incoming data additional products and statistics. This is all done on PC2, the processing server. Then on PC3, there is the monitoring, where you do all the visualization of the images and the statistics, and generate actually time series graphs needed for your reporting or your analysis. Okay. There are several flavors of the eStation. Of course, there is the Mesa station, the GMS and Africa station, which is actually containing 3 PCs. That is not correct, this here. It contains 3 PCs with 2 workstations. Then there is so the MESA GMS in Africa station is actually this construction, which has been delivered in I think in 48 countries in Africa already. Then there is also a Windows version. I will later on prepare a slide where where I will explain where you can get the Windows version and its installation manual. So you can also install a standalone version of the eStation, which is a complete version with the acquisition, processing, data management, and the analysis tool all available on your Windows machine. There's also a virtual machine available if you would prefer to work in a virtual machine. Then there is also a server version installed at the JRC for generating reference products. So that is what we actually have. At the JRC, we have a production server where we generate all the products over all of Africa. That can then also be downloaded onto your MESA station or Windows version if you use the Windows version, and update the missing data that you have. I will explain a little bit more about the missing data later on. So these are all the flavors. I think that you will be mostly working on a MESA station or a Windows version. Then during the course, we have also available an online version of actually only the analysis tool. I can show that to you. So this is the online version of the analysis tool. I will present mostly all the functionality of the analysis tool here on the online version, and you will also work here after being registered to the system to do your exercises. Okay. Are there any questions from anyone? Please feel free. Yeah? You can interrupt me whenever you want. Let me see if there are. Chats. No, nobody? Okay. So that was quickly. I think we are a little bit ahead of time. Let me see. Okay. So now I'm going to explain the application's main features. Unfortunately, I cannot show it to you because the online version has only the analysis tool, as Marco explained before. So I'm going to explain the application main features through some slides. When you open the user interface on the MESA station, you will see first of all the dashboard. The dashboard. So on the Mesa station, in this case, in the middle, you see PC2. Is it all visible for everybody, readable? Maybe I have to make it a little bit bigger. Okay. So as you can see in the dashboard, here we are on PC2 because PC2 is in the middle. In the dashboard, you'll see the overall status of your Mesa station, E-station. If you can see if PC2 where you are on sees PC1 and sees also PC3, then this arrow is green. If there is no connection between the PCs, the arrow becomes red. That means that there is a problem and that has to be solved by your system administrator. So what you can see here is actually an overall status of the E-station. If the services are running, I will explain a little bit more about the services later on. And if all the PCs are connected well, if the database is up and running, and if there is an internet connection, yes or no. Also, you see the active version. Yeah, okay, here you see version 2.12. This is an old slide. We are now already at version 2.20. Then on PC1, you see if the DVD is up and running well, if the telecast is running well, and if the FTS is running well. There is also data in synchronization. So the data comes in through PC1, is copied to PC2. PC2 does the ingestion and the processing, and then all the data is also synchronized from PC2. So the ingested data and the derived data is synchronized with PC3 where you do your analysis. So there is also a service for data synchronization and also for database synchronization. So all the changes that you make on PC2 in the database, they are synchronized to PC3 and vice versa. So the data that you change in the database is synchronized to okay, I'm not going to explain all the reasons for that. That is maybe a little bit too technical for you. So I go to the next slide. The second tab of the user interface of the E-station, is the acquisition tab, where you can control the acquisition of all the incoming products from PC1 or the internet. And you can check the log files of the services. So as you can see here, there is a unit cast service, an internet service, and an ingestion service. Who the three of them, they work independently, and you can turn them on and off or restart them as you like and see their log files. What you actually see here is, for example, for the rainfall, chirps is coming from the internet and is ingested over all of Africa. And it is a complete data set. There is only one file missing. So you see also the data set completeness in here. You can, in the acquisition, you can actually also, as an admin user, add by unlocking the acquisition tab. Here a button will appear, products, where you can add new products. of your interest, which is out of the scope of this training. But that is also possible here in the acquisition tab. What you can do here also is to activate and deactivate certain products so that they are not anymore acquired or ingested. So you can activate or deactivate also ingestions in here. Are there any questions on this? No one? Okay. Good. Then we go to the next tab, that is the processing tab, which gives you an overview of all the available processing chains on your station. What you see here is actually a sort of a schematic overview of the processing of each processing chain. So you see here the incoming product, then the algorithm that is used, and all the outcoming products. So in this case for DMP, over all of Africa, the long-term average is calculated, the max, the min, and the rate, some anomalies products. You cannot do much here except from activating or deactivating processing chains. And also for the processing part, there is also a service available, which you can start, stop, and see the log files in case there is some problem to solve. So all these services from the acquisition and the processing part, you see also in the dashboard. So here you have all the services available. In the dashboard there is also a system service, which is actually doing some housekeeping, emptying temporary directories, etc., etc., which is not really needed for you, but it has to be up and running. So that is the processing part. Then we have the data management part. Okay, here you see also the analysis, but that is normally not available on PC2. So on PC2, you have available the dashboard, acquisition, processing, data management, system and help tab, but not the analysis tab. And on the PC3, where you do your analysis, you have only the dashboard, the analysis, system and help tab. So this is the data management tab. Data management tab is for to see what is really on the system, what products are there, and its completeness. And the main functionality of the data management is actually to download, for example, here with this product here, you see that most of it is red. There are 65 files missing for this data set, which you can then download from our cloud service by clicking on this download button or this one. So if you click on this one here, then it will start downloading all the missing files of this particular map set for this product. When you click on this, a window will appear where you see a list of all the missing files, and then you say, okay, then you have here your requests, and you can see the status of the download. So that is very good for you also on the Windows version to start downloading some complete data sets over the internet. So for this part, you really need an internet connection. If you don't have that, the request, of course, will not work. I think that you will also, as a thematic user, sometimes look here in the data management tab just for to see if your data sets that you are working on are complete. And if they are not, that you can then update them by creating some requests. Are there any questions about this part? The data management? Nobody?
Hi, Julian.
Yes.
As usual. Okay,
Hi.
thank you very much. So for this part, I have a question. It's about the download option.
Yes.
Of the data. So here in Dakar, for our e-station, we have seen an error occurring when we try to request data download, such as, for example, connect proxy or something like this. And the suggestion you provided to us was to go to the request job directory and remove all files there and try again.
Yeah.
The first time it worked, but now even we remove all files there, we cannot have the data request. So I don't understand why, but it would be good if you can more elaborate about this.
That is on a Mesa station or a Windows version?
Now the Mesa station.
Mesa station. And you have a stable internet connection?
Yes, of course.
Okay. Okay, I will write this down, and then maybe in the break we can start discussing on this, because there are indeed some problems with the downloading of the data, so the requests. Most of the time it is caused by a proxy setting. So if your Mesa station is within your own company's or institution's network, and your institution's network is using a proxy, then you must set the proxy settings under the system tab. I can show that maybe here. Okay, that is not available here. So okay, I have to change the slide. So here in the system tab, you see also proxy settings normally, but I'm not sure if that is that is the case with you. So if you do have your Mesa station in your local institution network, please inform yourself if there is a proxy used, because otherwise, yeah, if there is a proxy used, you have to set the proxy settings under the system tab to be able to have it work.
Okay.
It could also be that your internet connection is not really stable. If it is not stable, then yeah, the requests tries to connect to our cloud server, but yeah, goes, let's say, in error, because yeah, in between there might be an internet cut down, let's say, and then the request goes in error. But yeah, okay, we can discuss this maybe during the break if you want. So.
Okay, I will let you know if we have the proxy option in the connection tab. Yeah. Thank you very much.
Okay. Anybody else? Some questions? Okay, so I go on with the analysis tool. So today we are going to work mostly in the analysis tool. I'm going to show you in the next part of this section all the functionality of the analysis tool as an introduction. So I can already explain a little bit from this slide. In an analysis tool, you can, as you can see, create map view windows where you show your product. In this case, it is 10-day NDVI filtered ratio, and apply also a legend to it. As you can see, there are several objects which you can manage within a map. You can add also vector layers and some other functionality that I will explain during the rest of this course. And you will also do exercises to create maps and walk through all the functionality of map view windows. Then there are actually 4 types of time series graphs. One is the profile graph. The other one is the cumulative graph. We have a matrix graph, a ranking zeta score, and a ranking graph. So these are all the available graphs. Also here you can fine-tune some settings of each graph, which we are going to see during session 2 of this course. And also there you will start creating all types of graphs during the exercises. Also, as you can see here above, there are workspaces in the analysis tool, which is very handy, which you can save if you are logged in under your account. Then when you re-log into the system, you will see the analysis, what you have been doing, exactly the way you left it, and go on with your analysis. Also, of course, the workspaces part will all be explained during this course. And also there you will have to do some exercises to create workspaces. And then with Christoph, start creating some workspaces of your interest and do your analysis. Okay. Then the system tab. Under the system tab, I don't think that you are going to be much of, you are not going to use much this part. You can see here all the directories where you can find on the system the data, and also some directories where the data is ingested, and you can change these, but yeah, it is recommended to not make any changes to these directories. Also, what you see here is the type of installation. In this case, it's a server installation which we use, and you will on the Mesa station see here type of installation is a full installation where you have PC 1, 2, and 3. The role of the of the PC. So this is PC2, in which mode you are, and the version. Also, as you can see here, it is an old slide. I have to update this one because we are at version 2.2.0. Then you see the thema. The thema is the one that you have, your system administrator has selected for you, for your institution, which actually activates all the products over your region of interest, all the products that you are interested in, and over your region of interest. So this thema setting has to be set in the system. And normally, if you have a measure station already, the thema has been set according to the installation instructions. If you are going to download the Windows version, also there you see in the installation instructions that after installation, the first thing that you have to do is to activate the thema of your interest, which you do in here. What you actually see then is here a modify button, and this one it will be empty in the beginning. So you click on modify, and then you select from a list the thema of your interest. That is mostly your institution name, and then you save, and the thema will be set, and you will see under the acquisition tab and all the products of your interest already activated, and also its processing change and the data management, which will be probably all empty. So you do not have any products yet, which you have to download then. Okay, this is also here you see the database connection settings. It's also a little bit technical for the thematic user. But if you ever need to connect to the database, these are the settings for to connect to the database using a different software tool, of course, to be able to connect to the database. So that is the system tab. Then we have a help tab on all the Mesa stations and also on the Windows version. Here you have available all the needed documentation. So there is a user manual, an installation manual, an administration manual, and a product report. You will be working mostly on the user manual and the product report. Christoph is going to explain more about the product report, and I will refer to you to the user manual during this course, but I think it is better to use all the videos that I have prepared for you that explain actually everything, all the functionality of the analysis tool, which you can find also in the user manual. You just click on it, and I can show it to you here in the online version. So here we have also a help tab. So also on the online version, you can just download here by clicking on it the user manual, which is a long manual, but everything is explained also for the data management and the acquisition, etc., and the analysis tool. And this is the product report, which Christoph is going to explain. So here you see actually all the products that are of your interest. Christoph will explain more about this later on. So in the help you have also some links, useful links. So there's the GMS in Africa website. There's also the eStation website, which is this one, where you can see also the latest news and also go to the web client of the online version. Here you have a link to the online version. So that is the eStation website, and there's the Copernicus website and also the UNITSAT website. And there are some notes if you're interested to read them. But I think that for the thematic user, the user manual is of interest, and the product report is of interest. Okay, any questions on this so far? No, so I go on. I'm going to explain some key, some essential concepts of the eStation. So that is actually the concepts of what some terms that we use, and I am going to explain these terms. So what is coming in is, are Earth observation products and their versions. They are actually, it could be that a product that is coming in is in a certain format of a certain version of the product. But it is all over all of Africa, and what you actually want is only, for example, the region of your interest, which can be, for example, only the north of Africa or the south of Africa. That's where mapset comes in. So we use the term mapset, which is actually the region of interest. And your incoming products are then clipped over your region of interest and ingested into the system only over your region of interest. So the products that are version that are coming in is then ingested into the system, and then the ingested product is called a subproduct. The subproducts can be also derived products. So there is an ingested product that is a subproduct, and also all the derived products that are generated by the processing chains, they are all called subproducts. Then we use the term datasets. The datasets actually is the complete set of time series of a specific subproduct. Okay. What actually is happening in the ingestion is that we ingest all the incoming products in a standard format, which is GeoTIFF. Okay, I'm going to explain a little bit better. So Earth observation products, as you can read, is a biogeophysical quantity describing the status of a component of the Earth. Land surveys, atmosphere, or radiation budget. As derived by satellite observations and numerical modeling examples. Examples are burnt area, DMP, FAPAR, LI, and DVI, but of course there are also oceanographic products like surface temperature and rainfall products like chips. A product's version identifies the specific collection of images depending mainly on the algorithm used for their computation. That is the global Copernicus global land products, for example. So a product and version is actually important to know that we distinguish this also in the system itself. Then the subproducts. So an acquired product might contain more than a single variable or layer. For example, spot vegetation NDVI has 2 layers, the NDVI itself and a status map, showing a quality flag for each pixel. What then is done, so the acquisition is done, or the ingestion is done in such a way that when the files of a particular product are acquired through EUMETSAT or the internet, then it analyzes as it's defined within its configuration what subproducts are inside the incoming product, and then both of these, or maybe only one, if there is only one subproduct inside the incoming product, are ingested into the system. So as I stated already before, after the ingestion, the processing chains create more derived products, statistics and anomalies, and also these are called subproducts. Are there any questions on this? I'll go to the next. So the map set. The map set is an ensemble of information defining a map representation of an Earth observation product. So you have the spatial reference system, the pixel size, and actually the region of interest, so the boundary box, and also the raster size, the X size and Y size. This is actually the complete definition of a map set. So it is not only the bounding box, but it contains also the spatial reference system, the projection, to be able to ingest well the incoming products into the system. Are there any questions on the map sets? So I can maybe show you.
Hi, Julian. I have.
Yes.
There is a question in the chat.
Okay.
There is a question, yeah.
You have to draw the can shapefiles be uploaded to define map sets? No. Okay, so can shapefiles be uploaded to define map sets? No, you cannot. do that. You actually, okay, I don't have a slide ready for that in here. So if you are in the acquisition and you enter as a user on the Mesa station and also on the Windows version, as admin user, then you can unlock the system here, the acquisition part, and get the possibility to open the definition of all the products, but also of the map sets. So maybe I can find that in the user manual. Sorry, no? Not sure. Yes. So here we see the unlock, and no, it is not. I don't have any slide for that. But yeah, okay, I will prepare maybe some more slides on this for maybe for tomorrow.
Julian, if I could just clarify why I'm asking about the shapefile. So I see that normally with the map sets, it's usually either in a box form. So it's either going to be a square or a rectangle. So in the case where the region of interest or the area of interest is more or less like in a polygon in an irregular shape, does it necessarily that all your map sets has to come in a box form?
Yeah, we define everything in boxes. Yeah, also because of maybe for performance reasons, or if you use a geometry from a shapefile, it can be less performant to clip all the incoming files over that over a geometry. So no, it is not possible to use a shapefile or actually a geometry to define your region of interest. We use boxes.
Yeah. Maybe I can also intervene here. Hi, Ignatius. No, we save, as you know, in GeoTIFF files, and this is just only rectangular regions. There is no really way to apply a geometry. You could clip and put some no data around, but still, when you save into the GeoTIFF, it's going to be defined as a number of lines, number of columns, so basically as a rectangular form. Maybe Vijay, Jurian, I can show a bit this map set feature on the Mesa Proc from the machine here. So I can share my screen. And this is actually an installation of a full A station we have here on our processing server, which is called Mesa Proc. So here we have on a single computer all the functionalities that Jurian was presenting. And under acquisition, once you unlock for editing the windows, you can go to product, and then up here you have a definition of a map sets. So you see all of them, and you can edit them this way. So you can define, and as you see, the image has a width and height. So it's really a rectangular shape that you can define, not really by drawing it, but by modifying here the coordinates, the upper left, lower right, longitude, and also the two boundaries for the latitude. So you can really simply modify it from here and then save it. So this is the you see that the area is reducing or expanding accordingly, and you can indeed save it at the end of a process. So this is the user interface which is implemented for managing all of them. I'm not going to save it indeed, in order to manage the existing map sets or area of interest, or also to create a new one. Actually, in the map set, you have different elements. One is the projection itself, so the coordinate reference system, the resolution that is also defined in the system, and the boundary box. So map set actually includes a number of elements, all the elements needed for georeferencing the image itself. So that is a bit the way it is implemented. Ignatius, does it answer your question?
Sorry, that's perfect. Yeah.
Thanks. So I'm Vijay, I'm gonna Yuri, and I'm going to give you the floor again, please. Yes, Julian, over to you.
Yeah, can I?
Yeah, try and share again. You're on a screen.
Okay. Okay. Okay, so if there are no any other questions on the map sets, then I go on to data sets. So data sets, yeah, is a jargon that we use to say actually, okay, an ensemble of images related to the same Earth observation products. So a data set is actually all the time series of a subproduct that are present physically in the file system of the e-station. That is called a data set. And okay, the data set is for a given map set, so a given geographic extent and temporal window. So it's a time series and also the map set. So a data set is defined by the product code, its version, subproduct code, and also the map set code. So this is how you identify a data set. I will explain that better in a session in the following slides when I talk about location and organization of the Earth observation data. So I hope that this is clear to everybody. Then, as I already explained before, there are several services on the e-station. A service is actually the concept of a service is actually the running, automatically running piece of code, let's say, that code that you can turn on and off and runs independently from all the other services. So it's if you turn on the internet service, so I can show you here there are 5 services. 1 and 2 are for the data retrieval. So there is an internet service and a UMITcast service, which work when they are turned on continuously. So when they are turned on, they are checking every tot seconds if there are if there is new data available on the data source, which can be coming from the internet or the UMITcast. And if there are, then they are copied automatically to the eStation. The same thing is for the ingestion. There is an ingestion service which you can also turn on and off. And when it is turned on, it is continuously, if there are new incoming files from the internet or UMITcast, ingested into, these are then ingested into the system. So what you can read here, the goal is to extract products from the retrieved native files. And these products are therefore stored in the standard eStation format. This is GeoTIFF. Then there is a processing service, which when turned on, runs all the processing chains that are activated to compute derived products, so indicators from existing ingested products into the system. So it computes then statistics or anomalies and saves them into the file system. This processing service, so these services are, when they are running, all automatic. So as a thematic user, you do not really need to know anything about these services, except maybe the processing on knowing how the computing is done. And it is all automatic, so you don't have to bother as a thematic user to administer all these services and understand more or less the technical part of how to get the data and how to ingest the data and how to process the data. Then there is a system service. The system service is actually a housekeeping service. So it does all kinds of background operations that are not involved with all the other services. That can be, for example, emptying temporary directories, making database backups, and etc., etc. So this is everything about the services. So I can show you also here that the services are all running on PC2, and that you can, in the dashboard, check, let's say, the status, if they are running, yes or no. Maybe there are questions on this part. So there is one question, what are the sources of data that can be downloaded from the station? Well, actually, by your thema settings, so the products that you are interested in, the JSC, so the eStation team, created all the acquisition, the sources from where the products are going to be downloaded. So you can do that also yourself. So you can also introduce a new product if you know where to download it from. Also, that is done in under the acquisition tab, but the sources. So I can maybe.
Yeah, maybe I can also intervene here because having access to the full version of Mesaproc, I can display how the sources are defined.
This here. So I don't know. So I don't see any sources here. Yeah, modus vapar. So where it is coming from? Yeah. Okay. So if you can share your screen, I will stop.
I will. Yeah.
Okay.
Indeed, this is a very, very relevant question. You see that we have different categories of products, and from this acquisition tab, you see both the list of the products that are there, and also the definition of the data sources here, where you get them from. Then when you enter there, you see how is the data source defined. So in this case, is an HTTPS server, which has not really credentials, and you define a kind of regular expression in order to match the files that are into this directory. So there are different types of acquisition. We can also get Copernicus online data. In some cases, it's very simple, so it's just an FTP or HTTP server, sometimes with some credential for user registration. Sometimes it's a real API, like the one for Sentinel or for GeoDPP, which is a JSC big data platform. So you have different ways, different procedures. In some cases, like that one is pretty simple, and in other cases is much more complicated, and we had to establish real communication through an API with the data provider. But if you really refer to the provider, data provider and the sensor we have access to, you will find more information within this products report, where we define all the products we have on the station, and also the definition of the data sources. So here you see all of them, they are defined. Yeah, hope this does answer your question. Indeed, it's not only MODIS. We use for the vegetation category mainly product based on the Copernicus Global Land Service, and they are based on ProbaV. Until this summer, they were only based on ProbaV. Now there is an ongoing transition to the Sentinel-3 OLCI products. Then we use products coming from MODIS, but also from Sentinel-3, like in this oceanographic category. So we have also Sentinel-3 CLA from OLCI and Sentinel-3 sea surface temperature from the other instrument CL SRT. Then we have also data from MSG, for instance, which are delivered by LSA SAF in Portugal. So in the documentation, there is a precise description of all the data set we use. So I just suggest you to go to this document, which should be uploaded in the reference material of this training, or is going to be made available very soon. And then you find the information you need. Okay, thanks. I think we can proceed. I think you can proceed, Julian.
Yes, looking at the agenda, is it good now? Because I'm a little bit behind. I should start explaining the location and organization of the EO data, but I see that it is now break time. So do we want to have a break, or shall I go on?
How long would it take to cover this part before we're back?
Well, another 15 minutes, I think, 10 minutes.
I don't know. Meshaka to me is good anyhow.
Yeah, for me, we can actually complete if it's not going to take too long, and then we have a break. But it all depends on how Urian feels.
Okay.
Urian, are you okay to continue?
Yeah, I'm okay to do that.
Okay.
Yes. Okay, so now I'm going to talk about the location and organization of the Earth observation data. This is to explain to you how you can find on the e-station the data that you are interested in, and maybe copy them and open them in other software, like for example Envy or QGIS or ArcInfo, any tool that you would like to use. So the file system overview, not only the data that you are interested in, so all the data sets, but also I will explain where the code is, and the temporary directories, and also where you can find all the vector layers. So the code on the system you can find under var www eStation2. I think that is not really interesting for you unless you want to start to change the system and code. But anyway, so this is the place where you can find all the Python and user interface code, JavaScript code. So, okay, everything is written in Python, by the way. So then the temporary directory, that is a working directory, which is actually cleaned at every reboot, but I think also in through the system service. Here in this temporary directory, temporary files are stored, for example, during a processing chain, when there are temporary files to be used. They are all stored in here and then cleaned up later on. So for each for the services, there are the PIT files for the services, and also the processing chains. They are all under temp eStation2 processing directory, and some other working dirs. So this is the place where you can find all the temporary files. Then there is the slash from the root eStation2 directory, where you can find several other directories. The one that is most of your interest might be the layers directory, which is under the eStation2. So there is also a layers directory where you can find all the vector layers that are available on the system. So for example, I can show you quickly that in a map you have here all kinds of border layers available, and the marine layers, and some other layers, like for example protected areas. These are all vector layers that you can use in the analysis tool, and they are under the /eStation2 layers directory. Okay, then there is the data directory. So under the /data directory, all the data sets are stored that are ingested and processed as the derived products. So how is the data directory organized? All files are stored in the base processing layer, which is actually /data/processing by default. This you can change under the system tab, but I recommend not to do that. So under this directory, you can find all the data. And how is it then organized? So under the data processing, for each product, there is a directory with its name is the product code. Then under this directory, there is another directory with the version of the product. So for example, VGT NDVI, which is the product code of NDVI, spot version 1. This is the version of VGT NDVI. So for native products, there is another directory where you can store where the native incoming product is stored. Then for the ingested products, so under the product code version, there is the map set directory, and the ingested go under the map set directory, under the TIFF directory, and then the subproduct code. So for example, data processing NDVI spot version 1, map set code, which is a directory, and then a TIFF directory, and then the subproduct code, which is NDV. So under here, you can find, for this particular subproduct, all the time series. I'm going to show that anyway through a video. So for derived products, it is instead of mapset TIFF, it is mapset derived, and then the subproduct code. So for example, data processing VGT NDVI, spot version 1, mapset code, which in this case all of Africa, then the directory derived, and then a directory for the specific derived product, which is 10-day max in this case. I hope that it's clear. Any questions on that? Then the file naming. So under, for example, this NDV directory, all the files of every date of this product that are available or downloaded or ingested in this case. They have also a format of the file name. So the file naming is as follows. There's first the date, an underscore, product code, underscore, subproduct code, underscore, map set code, underscore, and then a version, .tiff. So for example, for a DCAT product, like this one, there's the date, which is full date, then the product code, the subproduct code, the map set code, and then the version, .tiff. So for every date of this specific product or data set, there will be a file changing only the date. For example, for statistic products, the date is different. This is a monthly statistic. No, this is a day statistics, not a monthly statistics. 10-day average. The date is, of course, without the year, but the structure remains the same. So, product code, subproduct code, map set code, and version with the date in front of it. I am going to maybe show this to you. So I can go to, so in the slides there is a YouTube video which actually explains the file system on the Mesa station. So as you can see here, we go to the root directory, then to the data directory. Under the data directory, you have the processing directory. There is also an ingest directory, but it's not so much of interest for you. Also an ingest one for the files that are incoming that are not correct, and they go in ingest one. So then here we have the data processing directory. As you can see, we have here a long list of all the products that we have on our system, starting with the product code. So for each product, there is a directory with its name, the product code. Then there is the version, then the map set, then you have the two derived and TIFF products directories. And under there you have, for example, the one-day product for this subproduct for this particular product. And you can see all the time series, so all the TIFF files for each date, starting with date, product code, subproduct code, map set code, and version. Same thing for the derived. So as you can see on the derived, we have 5 for this product, 5 derived products. And they are actually the same. They have the same naming, but they are on a different directory. I can maybe go back. Derived. So as you can see, for the 1 month average, they are under the derived directory, the subproduct code, and then you have all the TIFF files available for this particular data set. So this 1 month is what we call a data set. I let the video go until the end. That was it. Okay. I hope that is clear. There is also a video available how to find the documentation, the log files, the settings, and the downloaded data source list. If you want, you can watch this video yourself I just added this to the slides, but it is not needed to understand how the file system works. So this video is just for to show you exactly where the place where you can find all the data sets if you ever want to copy them and or use them on the QGIS software that is also available on the measure station. So I think that is it. Are there any questions? If there are no questions, then we can go on and have a break.
Okay, yeah, thank you so much, Urian. How long is the break, by the way?
I believe it is 15 minutes. Yes.
15 minutes, okay. Thank you so much. So, so we stay on board and we meet after 15 minutes.
Okay.
Okay.
Good.